Hi, I'm Akhil. Now in this video, I'll show you the demonstration of LabFile, that is fast and reliable file transfer. For this experiment, we are using UDP/IP protocol to transfer the file between the server and the client. The main objective of this experiment is to transfer a 1 gigabit file over a link of speed 100 Mbps and check the performance during various RTT delays and different loss rates. Now, to get started, we'll go to isi.datalabs.net, enter your credentials, and now here inside. Now I've already created a lab which is already swapped in with the basic NS file which will create two nodes and with a link speed of 100 Mbps. Now we have also created uh, now for the transfer of these files we are going to use two programs, that is server udp.c and client udp.c. These are the two codes of server and client which we have already transferred into the testbed using FileZilla. Now we can see if they are present in it or not using terminal window, because one we need one for client and one we need for the server. And now we will SSH enter the password. Now we can see that we are inside the testbed. Do the same thing for this thing also. Enter the password. Okay, you are inside the nodes. Now open the FileZilla to see the files we have transferred. Okay, the first one is USC 542. Okay, sorry, at users dot ISL dot net. Username is USC. To DK. Password I can't tell you. It is 22. Open it. Now you can see that we have a server udp.c and we have client udp.c. Uh, Now I'll show you the code which we are using for the file transfer. This is the code, and here you can see that the data size which we are using for this experiment is 1500 bits, and we are also using pthread so that the file which we are sending will be read very quickly. And this is the statement which will give us the time, the file size, and the throughput. And this is the client UDP side. Here also you can see that the data size of the data packet is 1500 bytes. And now I will show you the methodology that we are using for this program. For the client side, first we'll set up the UDP sockets and then read the file from the memory, that is a 1 GB file which is already mounted in a temp directory. And now this file has to be sent to the server side. And before sending it, the file will be fragmented into small packets and sent packet to the server. If there is acknowledgement that all the packets are sent, and this can be done by the checking the sequence number. If no, then the lost packet will be sent again. From this side, this is same as the server will acknowledgement which packets are lost, and the client will recreate the lost packets, and the packets would be sent to the server again. And again, the server will check if there are any packet lost by the help of the sequence numbers of the packets. And if there is no packet, any more packet lost, then the file transfer is complete. And now we will see the server flowchart, which we are using. For the server side, we will set up the sockets first and receive the file size from the client, because this is very important, because in this step only the server understands what is the size of the file which the client is going to send, and it will allocate the memory for the data which is coming from the client. And now from we'll go to the server will receive the client from the packets from the client, and it will write those packets packet data to the memory, and if it will check if it is if the packets are all packets are available or not. If not, it will go and check what packets are missed and request the packets which are missed to the client, and if all the data is received, the file transfer is complete. Okay, so these are the methodologies that we used for this experiment, for the client side, client UDP and the server UDP. Now I will show you the exact demonstration of the experiment. For that, we have to first see the modified traffic shapings. We'll first set the delay as 0, one way, and the loss also to be 0. Execute, and you can see that the delay is 0 and the loss is 0. And now, first, to perform this experiment, we have to SSH into the nodes. SSH and go to experiment to see what is the exact name of your node. Details. This is the qualified name of your node. This is node A, which this node A is going to be the server side, and node B is going to be the client side. Now we are inside this. Now we have already created a 1 GB file in the temp folder. To check that, we'll go to cd slash. Here you can see that the file is already there, data.bin. And now we will check the file transfer with zero delay and zero loss. For that, this is the client and this is the server. We will first compile the GCC threads, pthread, sorry. Or server UDP. Sorry, this should be capital. And the same thing for the client as well. C1 empty. Empty. Now we have done it. Now we will run the server. Server UDP. Give the power port number some random port number. And now first we will go into this. Now we will go service client UDP node A, which is a destination, TMP slash data. Oh, we have to give the node as well, 2000 space 10, the file name, which is data.bin, and enter. It will take a few minutes to transfer it. Here you can see that the throughput is 76.98 with zero delay and zero loss, which is quite good. Now we will check for other delays and other loss percentages. Now, as per the question, we are supposed to find the delay with a throughput with a delay of 10 milliseconds, the loss rate of 1% for the two links, which would be the delay is 5 and the loss percentage would be 0.005 because it is 1% and it is for single link. Execute the program again. Sorry guys, I forgot how to do the MD5 checksum to see the integrity of the file. For this, we have to check. Uh, no, just a second. I'll show you the file received. cd/tmp received file here because this is a data.bin and this is the received file which is renamed in the server side. And now we will see the MD5 for the integrity of the file we received, which is MD5 sum space slash temp slash re file. The same thing for this thing also. MD5 slash tmp, that is the space over here, slash data.bin. Here you can see that both the numbers are the same, which means that the file was sent and the file received is the same. Now we will check for the other in the traffic shaping. We will remove this received file just in case. Remove received file. Control C. Okay, we'll see. There's no file in it. We'll do it again. cd, go into home directory. Now, now we will again initiate the server. UDP, it's on. Now here you can see for a delay of 10 milliseconds and the loss of 1%, we received a throughput of 76.98, which is almost equivalent to the throughput which we got with zero delay and zero loss, because the delay is very small and the loss is very small. So we are almost getting the same thing. So now we will check if the file is received or not. For that we will go to cd/temp ls, and you can see there is a received file, which means that the file is been transferred successfully. Now we will check the integrity of the file by using the MD5 function in the client and server both. Here you can see that both are same, 04FF, 04FF, that means the integrity is same. Now in the next part of this experiment we will increase the delays uh, to 20 milliseconds, that means 10 milliseconds per each node, and a loss of 20%, that is 0.1 per each link. And now we will execute the program. First, we will remove the received file ls, so it's not there. Now we'll go to the home directory. Now we are in. So we will run the command again. Now we'll transfer the file. It will take a few minutes. Here you can see that we got a throughput of 41.0 with loss of 20% and RTT delay of round trip time delay of 200 milliseconds. So that's good. And as the next part of the experiment, we have done for other parameters also, which I'll show you here. This is for no loss and no delay. We got a throughput of 76.9. And for a delay of 10 milliseconds and loss of 1%, I got a throughput of 76.943, which is almost equivalent to no loss and no delay throughput. And I also did a file transfer when the delay was 100 milliseconds and the loss of 10%. Here we can see that the throughput went down with to 69.2, and the throughput for a delay of 200 milliseconds and loss of 20%, the throughput was 41 megabits per second. We have completed LAF5, which is fast and reliable file transfer protocol using UDP. Thank you.